All right, hello everyone. Thanks a lot for coming to my talk. As you can see, the title for this session is a platform-agnostic approach to securing workloads. By show of hands, is anyone working with SPIFFE or SPIRE in their environments at all? Okay, oh, a couple of hands. Okay, great. Well, hopefully for those of you that haven't had much of a hands-on introduction or understanding of it, this will be a great way for you to get started with it, as well as have some key takeaways for your particular environment. My name is Lukonde Mwila, and I'm a developer advocate at AWS, specifically in the Kubernetes team or the Amazon EKS team. I'm also a CNCF ambassador. For any of you that are interested in connecting with me, please feel free to do so after this session, or if you prefer to do it online. I'm relatively active on LinkedIn as well. And for those of you that enjoy watching cloud-native content, you can check out my YouTube channel. Just search for me using my full name. But I'd also encourage you to check out the AWS container-specific channel called Containers from the Couch. All right, so I thought I'd start off with a story that some of you might resonate with, but I'm also hoping it will set the stage for the rest of the session. A couple of years ago, I was part of a platform team at a financial institution, and we were rolling out a new digital product to the cloud. This particular product consisted of a number of microservices that were highly integrated with a number of services on-premise. Now, I thoroughly enjoyed my time working on that project. However, there were also a couple of unpleasant experiences, like most projects. And some of them are still hard to look back on, but I hold on to those memories because they serve as motivation for different initiatives in the present, like this particular topic, which I'm passionate about. On one occasion, we were rolling out and testing a new version of this digital product, and things weren't going well. Can anyone relate to that? So this was well past the hour for dinner, but still several hours before breakfast. And there's only so much pizza you can eat to keep you going, right? Now, we found ourselves in somewhat of a treasure hunt, and that's putting it in positive light. The treasure in this case was the expected or desired responses to API calls that were being made from services in the cloud to the services on-prem. We were encountering a number of issues that needed to be clarified for us. So we started engaging with a number of the different teams responsible for the services and subsystems on-premise. So we would engage with folks from the team that managed microservice B, for example. They would help us resolve that particular issue. But then another thing would crop up between our system and microservice C. And this was somewhat recurring, and a lot of times this was due to the fact that we were juggling multiple security identity models in the larger software architecture. Now, the good news is eventually we got to our treasure. But I don't want you to be captivated by our well-oiled system or to distract you with that. I'm going to focus on the issues. I believe that what we faced then was, or is rather, a portrait for a modern-day challenge, and that is most modern enterprise systems are very complex and convoluted, and that's not going away anytime soon. Ultimately because a number of companies and teams are devoted to enhancing their digital products, and that process usually comes with a number of different things, such as microservices, which is a usual suspect. Microservices are single-purpose elements, they're modular, they have an independent lifecycle, making them relatively easy to introduce into a larger software architecture. If a new requirement crops up, you can develop a single-purpose component that will specifically address that requirement. And on it goes, but before you know it, you're actually adding to the larger complexity. In addition to that, there are a number of teams that distribute their services between the cloud and on-prem. And as they distribute these services, a lot of them still talk to each other to fulfill specific requirements or objectives, just like we were doing in my particular case. For some teams, even though I find that this is still in the minority, they distribute their services across different cloud environments, and those services still have to talk to each other. Excuse me. Now, even within a single organization, you also have distinct applications that are independent of one another in the different business units, but once again, there are times when they have to talk to each other. And the reason is companies and teams are creating larger ecosystems to enhance and better improve the kinds of products that they're working on. But that typically comes through these different kinds of processes that I've just mentioned, from microservices and the kind of distribution that teams are going to go with. In some cases, these integrations can be with entirely separate organizations. Now, at a micro level, this might look relatively straightforward when you simply have to integrate microservice A with microservice B. But when you take a step back, at a macro level, you start having a larger web of complexity, which isn't so straightforward. A number of services are now making calls that traverse different network environments, different systems that have their own standardizations and their own life cycles, some of which are completely outside of your team's control. So in a nutshell, the modern system is not only complex and convoluted, it is widely distributed and heterogeneous in nature, consisting of microservices, monolithic systems, legacy systems, and cloud functions. And as long as companies and teams are continuing to enhance their digital products, this web of complexity will continue to grow. Now, there is a major security implication in this particular case. With all these services that are communicating with one another, and with more services being added into the mix, your larger software architecture or your web of complexity is becoming highly dependent on the network in order for that service-to-service communication to take place. And that security implication is, how do you keep track of who is who in this large, complex environment? Because that is extremely important given the sensitivity of the information, but not only that, trying to maintain certain policies and standards within your organization or within your department when there are multiple integrations across the board. How do you secure the communication between these workloads and have a mechanism in place to validate the peers so that in the case that there is some kind of interception of a message, it is not easy for that unintended party to deduce that particular message. So the key objective over here is securing the larger web of complexity by having a validation mechanism between the peers and encrypting the traffic between the different services. Now, some of you might say, well, perhaps the easiest way to solve this particular challenge is to make use of the existing security identity models associated with each application. And that's one approach. How about we just integrate these distinct security identity models? But that's actually very similar to what we were trying to do, and we faced a number of issues. And as fun as our treasure hunt was, I certainly wouldn't want you to go through the same experience as well. Juggling multiple security identity models can easily result in these kinds of issues. For starters, you're going to be engaged in a number of ongoing meetings and exercises between your platform, security, and development teams that will be trying to align on the different security identity models, and also trying to understand what threat modeling looks like across the board. And this will continue to happen as long as more services are being added into the mix. Then the outcome, or the implementation of those meetings, provided that they are positive, is actually going to be borne by the application developers, who will also have to take care of the cognitive load and actually modify the source code for the different workloads in order to cater to the different identity models that are being juggled with every integration that takes place. And as good as your application developers are, there's a high chance for security misconfiguration over here, because it is a difficult thing to do. Security in software is relatively complex, and the more security identity models that application development teams have to juggle, the harder it is to always cover all the bases. Now, the complexity and difficulty in this particular space leads some to simply kick the can down the road. I've engaged with a number of teams that actually fall in this particular category, and I can't blame them. It is challenging. But the problem with kicking this particular can down the road is that it gets bigger and heavier the more that you kick it, because it's highly unlikely that your system or software at large is going to come to a standstill in terms of more integration and more enhancements. So that means the overall complexity and size will continue to grow. But by implication, that means that the requirements to secure it will also continue to grow in complexity and size. So it's not something that you should be deferring. Whether you decide to take on the behemoth-sized task of juggling multiple security identity models or deferring it altogether, you may be positioning yourself in a really bad way because of the risks associated with not having a security strategy around this web of complexity. So that begs the question, how do you actually secure workloads and the interactions between them in this large web of complexity? And I'm going to walk through or propose a universal mechanism for attestation and identity issuance using SPIFFE. But let's start off by understanding why we would even bother with a single universal standard. Well, for starters, it will alleviate a lot of the risks that I spoke about that are specifically tied to juggling multiple security identity models. In addition to that, part of our objective should be to have a secure foundation across the board of this web of complexity that allows us to continue to have enhancements. We don't want to inhibit that particular evolution. Our software will continue to change. There will be more enhancements and more integrations. So we need a single thread that can cut across the board, allowing for further enhancements, but not compromising on security at large. So basically looking for a scalable mechanism that supports the evolution of the software. But what does it mean to have a single identity standard in a large web of complexity? Well, by that, I mean every single workload must start off from a particular position of no trust whatsoever. No implicit trust at all. It must first, each workload or piece of infrastructure must first go through a process of attestation or being validated according to a specific criteria or set of configurations. And only after that is fully satisfied should it then receive a digital identity and proof of that digital identity and be allowed into a trust domain. And that's a big part of it as well. Building a domain of trust that envelopes or encapsulates the entire web of complexity. So that way, instead of trying to build a web, instead of having a web of complexity first and then trying to secure it, you start off with the foundation of having a domain of trust that you then allow workloads to be a part of and to participate in. But what does attestation actually look like in this particular process? Well, it's not too different from the real world. When I was getting my national ID, I had to avail myself. I had to present certain documents and pieces of information, and I was interviewed by a particular authority, and they were interested in specific pieces of information. They didn't care much for the name of my pet, as much as I loved my dog at the time. They didn't care for the high school that I attended. There was a specific criteria that they had. And in the same way, you can have a pre-configured criteria or pre-configured set of characteristics that you expect your workload to satisfy or your infrastructure before allowing it to pass this test of validation and then receiving the relevant digital identity. Examples of this could be a Docker image ID. It could be the service account associated with a particular workload. It could be a container or the set of containers that you expect to see for a particular workload. For a piece of infrastructure like a node in a Kubernetes cluster, it could be the cloud environment that you expect it to be running. It could be the namespace that a workload should be running in. And the more of these characteristics that you list and have defined, the higher and thicker the wall is that you are building before something is allowed to cross over and be a part of your trust domain. And I want to explore this a little bit further. Years ago, when I was working at a consulting firm, I received a company card. And this company card was proof of my employment status and my employment identity, and it gave me access to our Johannesburg offices. Now, while I was working for that same consulting firm, I was consulting at the financial institution that I was referring to earlier. Now, when I first showed up at the financial institution, my company card from the consulting firm didn't count for much. Have you ever had that moment where you use your access card and it's just not working? Anyone had that experience, or am I the only one? Okay, a couple of people. Great. I guess the real question is, what were you trying to do? Were you supposed to be trying to access that? I'm just kidding. So the reason that was happening is because these are two separate entities. They're essentially two different trust domains, and they have their own respective authorities. And so I first had to go through a process of attestation at the financial institution before they issued me a company card. And if I happened to be engaging with 4 or 5 other companies at the time, that would have been more access cards that I had to juggle. And that is akin to what a number of microservices and the application developers responsible for them are having to undergo every time that they're juggling different security identity models and continuously modifying them to cater to the different domains of trust and the different issuing authorities. But what's more desirable is to have a passport-like system. So I have a single passport that I use for the different foreign nations that I go to. And each foreign nation essentially functions like a trust domain, and they have their own issuing authority. But there are also bridges of trust between these different foreign nations and my country of origin. And I just have to use the single document, which when I first show up at a country, they first test it for its legitimacy, and only after it passes that test do they then use it to verify that I am who I say I am. That moment where they hold up the passport and look at your face. I actually had one moment where I was wearing my glasses, and this person started looking at me a lot of times, and I was like, they can't be that much of a difference with the glasses on, surely. And there was a person behind me who cracked this joke, and he was like, are you who you say you are? So I haven't forgotten that. That's only ever happened once. But that's something that we can essentially translate to the digital space as well using SPIFFE. And SPIFFE stands for the Secure Production Identity Framework for Everyone. And this is an open source framework that consists of different specifications or standards that allow you to have a universal mechanism for attestation and identity issuance. And you can have a standard API that you use across the board in this web of complexity, a universal or a standard API. And granted, there are approaches where you could use native libraries, but I'll be focusing on how you can use Envoy in this particular context. And because it's interoperable, that means you're not locked in specifically to using this within the Kubernetes domain, because it's highly likely that your web of complexity consists of workloads that are outside of Kubernetes, outside of the cloud, and potentially running on-prem. Now, I'm also going to be focusing on SPIRE, which is actually the production implementation of these specifications, these SPIFFE specifications, that is. But the next question that we have to ask is, how can your workloads receive these interoperable or platform-agnostic identities without impeding the application development lifecycle? And there are essentially two problem domains over here. One is the attestation and identity issuance component, which is addressed by SPIFFE. But then there's the actual process of security configuration. How does the workload actually receive this particular identity that it can use, and how does it validate its peers in the web of complexity? And how do you accomplish that without, as I mentioned before, inhibiting the application development lifecycle? You want to avoid the cognitive load on your application developers. And that's something that Envoy can address because it deals with the application networking concerns, but in addition to that, it can also deal with these particular security configurations to receive these platform-agnostic identities. So these are the two problem domains that are solved by SPIFFE and by Envoy. But then how do we marry the two? Well, the two come together using the SDS protocol, or the SDS API. And the SDS protocols, SDS in particular, stands for Secret Discovery Service. And this is an API that manages certificates. Specifically, it allows you to fetch remote secrets that contain certificates for a particular workload. In addition to that, the material that is necessary to validate any peer that is claiming to be part of the same trust domain. And so if you take a look at this diagram over here, you'll see that there is an SDS server component within the same block that has the SPIRE agent at the bottom. But essentially, because both SPIRE and Envoy support the SDS API, the SPIRE agent can essentially act as the SDS server, which pushes the relevant certificates to the Envoy proxy. And the Envoy proxy receives the certificate, which represents its SPIFFE identity, or its interoperable identity, as well as what is known as the trust bundle. And the trust bundle contains public certificates that allow it to validate any peers that are claiming to be part of the same trust domain. And in this diagram over here, you'll see that I have two workloads, microservice A and microservice B, each one of them fronted by an Envoy proxy. And the Envoy proxy is communicating with the SPIRE agent. So the SPIRE agent is what is functioning as the SDS API server, and it pushes the relevant SPIFFE verifiable identity document or certificate to the Envoy proxy. And the Envoy proxy will receive its certificate, which is the representation of its identity. In addition to that, the trust bundle. And then when these two workloads want to communicate with one another, you can essentially set up mutual authentication so that these peers can validate one another before any communication takes place. And I want to speak briefly about the SDS configuration before I transition to the demo. So there are a number of fields when it comes to SDS configuration, and this is all going to be contextual depending on what you're trying to accomplish. But there are two primary fields that I want to focus on. The TLS certificate field is used to essentially define or fetch the secret that's going to contain the TLS certificate for your particular workload. And then the certificate validation context is the component that, or is the field rather, that is used to fetch the trust bundle for that particular trust domain so that you can configure so that you can configure validation of any workloads that are trying to communicate with your particular proxy. Now, before I get to the demo, I just want to quickly show you an overview of the architecture so you know what's going on under the hood. So I essentially have a load balancer that proxies traffic to an edge proxy, which is just the Envoy component that first receives that traffic. And then that edge proxy, which is essentially an Envoy container, receives a SPIFFE identity from SPIRE. And that is the certificate that it will present to all the upstream components. In this case, the upstream components are the GraphQL API, the Orders API, and the Products API. Each one of those other microservices also receives a SPIFFE ID. And those are the certificates that they will present to any of their peers in an attempt to communicate with one another. And only upon successful validation will there be successful encrypted communication between them. And in case you're wondering what is ACM-PCA doing right at the top over there, you can set up an upstream root authority for your SPIRE server, so that is what I have done, but SPIRE has its own CA as well, and you can set up another CA if you want your upstream root authority to be cert manager, for example. And I briefly want to cover some of the important components in this. So I've highlighted the specific areas to focus on. So over here we have downstream TLS context. So this is essentially validating a request that is coming from downstream, and you can see under the yellow, or rather just above the yellow line, we have required client certificate, which is essentially saying we require that certificate to be presented. This is for mutual authentication. And then you'll see under the common TLX context, there is the pinkish block that I've circled over there, and it shows the name of the particular certificate, and that is essentially a representation of the SPIFFE ID, so that is what is represented by the X.509 certificate. And then right at the bottom over there, we have the orange block, which says combined validation context. And this is the same area where we define the trust bundle that is to be fetched, which is right at the bottom over there for the particular trust domain. But in addition to that, I've added additional configurations saying, even if something is in the same trust domain, I only expect to have workloads communicating with me if they match these particular certificates that I am expecting, which just adds another layer of security. And over here is the upstream TLS context. So that was downstream, but now this is in a case where a client is communicating with a server. Once again, that pinkish block you see, so that is the certificate owned by the particular workload that this Envoy proxy is associated with. In this case, you can see the suffix is order service account. And then right at the bottom, we have the block for the validation context. Okay, demo for real this time. I'm just going to zoom in a little bit more so that this is as clear as possible. And so this is the GraphQL API, which is communicating with orders and products, and all of the necessary validation configurations have already been put in place in Envoy. So if I hit play over here, you can see that I'm getting a response over here. The particular query is to fetch orders, and in that, fetch the order ID, who the order is for, and the associated product, including its ID and name. So we're just going to look at the first one over here. We can see who the order is for, the ID of the product, and the particular name of the product. And over here, this is a response specifically for the Orders API. And remember, the Edge proxy is what's fronting all of these microservices. So the Edge proxy successfully communicates with GraphQL, and then GraphQL in turn successfully communicates with orders and products because there is successful peer validation in between each of these workloads. Now in this case over here, this is simply between the Edge proxy and the Orders API. This is the same as well in that this is between the Orders API, the Edge proxy, and the Orders API, except it is a nested request, so Orders is also communicating with products. So again, there is successful communication between them because of the validation taking place. And the last one over here is just to show you a failure. And the reason I put this here is to show you that specifically the certificate verify failed because I purposefully misconfigured the certificate between the Edge proxy and the products API. I misnamed the certificate in the match URI details. So the Edge proxy is essentially expecting a particular certificate to be presented, whereas products is presenting something else, hence resulting in the verification failure over here. And that brings things full circle.
Great, thank you. Any questions? Do you know if there's going to be any work to get the AWS managed services, like an RDS or something, to start accepting this form of machine ID? Like, I'd love to put my own microservices in the same trust domain as the PaaS features I use in AWS.
Right. So at the moment, there's support for SPIFFE and SPIRE, particularly in app mesh. And if I'm correct, I think that is the same even with Lattice, because Lattice uses the Envoy proxy under the hood, but no particular managed services at this point in time. However, if you're interested in something like that, I did create a container issue on the AWS containers roadmap for a managed Spire. So if that interests some of you, you can go and give that a thumbs up. That's one way of pushing the initiative forward.
So one of the things that I saw in this is you have to have services that are aware of who is calling them and who they're expecting calls from. And that doesn't seem, in the complexity of a microservice environment, very scalable or very useful. Is there anything to be done around, I would like to be using something like Spiffy or Spire, but I'd just like to be accepting, you know, universally acceptable tokens from any service in my environment as long as they're okay, rather than I only accept service A and service B.
Right, I see. Yeah, so what I demonstrated specifically was how you can get as specific as I'm only expecting service A and service B. But if you want to go if I could say a level lower, where it's specific to the trust domain, you can omit that, where you're matching the specific URIs or the specific Spiffy IDs. And then any workload that participates in that particular trust domain will have successful communication. So for example, with what I showed, where that was essentially a custom Envoy mesh, you could essentially configure that with Istio as well, where Istio is participating in the same trust domain with the same root authority, or even if you federate the roots of authority, and you can have successful communication between the two. That will still give you that mutual authentication and that validation of peers without having to list every single one of those. Sure.
All right, any more questions? Oh, okay. Yeah, do you want to?
Right. Okay. So the question is essentially does this support any kind of attribute-based access control? And so I would say one approach to this, and I hope I communicated this in the right way. This is just one layer of security in the web of complexity. So this is specifically for the security identity model, but on top of that is authorization and access control. And so this can essentially be an enabler for that attribute-based access control, where you can add additional layers of specifications. Whether you go with OPA, for example, and you start having more fine-grained details on what's allowed after you've passed the particular Spiffy identity. And then just perhaps some attributes as well, is I'm thinking specifically about the selectors associated with what your criteria essentially for validating a particular workload. So that is dynamic, and you get to define those particular attributes that you want. I simply shared earlier that the more you have of them, the better, but that is not rigid. It's not like there's a hard requirement in terms of saying that you have to have at least 5. So you could just have 1, for example. Does that kind of help or answer your question?
I think so, but like a lot of that is like at the beginning when you're like first like sending in some type of workload, right? And after you bypass that gate, there's not really like any associated like validate.
Perfect, yeah. So I think then more specifically, that would be the access control. And like I said, so you can integrate it with OPA, for example, so that you can have more fine-grained controls when it comes to that particular authorization mechanism as well. You can also use role-based access control as another layer of access control. So this is just the foundation, and then you build on top of that with additional authorization mechanisms.
So I have a follow-up to that one. What information in the certificate or the trust computation is passed by the Envoy proxy to the downstream server?
Specifically from the Envoy proxy to, is this between Envoy proxy and the workload?
Yes, yes. What kind of attributes are passed about that certificate that was used to authenticate the workload, to authorize the workload, right?
Right.
So that, yeah.
Cool. So the Envoy proxy is representing the particular workload, and so there's no encryption between those two in particular. the validation process takes place essentially between SPIRE and the Envoy proxy. And that validation process is what's essentially running based on the attributes that you define, saying, can you please check for these particular items or this particular criteria before validation passes as a check. Is that?
No, so what I'm asking is that everything works as your demo, right, on the first two tabs there. But what can the workload know about the upstream? Is there any ability to inject or annotate the data coming to the workload that it has properly passed through that Envoy proxy? Right. And like, what are the remote endpoints parameters, right? Because I'm thinking through how we would use something like OPA just based on the layer 3 connection information that we're getting. Like when you have a load balancer, usually in line somewhere around the SNI area, you can get an embedded ID of the remote IP that you can trust. I was just wondering if there's any information coming in from Envoy extra from the actual workload.
Yeah, no, that's a great question. I'd actually probably have to explore that one a bit further because I was emphasizing more on the decoupling the application development lifecycle from Envoy, but that's a great one because there's certainly cases where you would want to actually attain some of the information from a workload that's communicating with that particular microservice. That was a great one. Thanks.
I can actually answer this for you, and you can include the entire certificate as a header, or you can extract some properties if you don't want to send the entire certificate. They can be very expensive. So you can extract SAN or I don't remember all the API, but there's a specific API where you can extract the properties, put them in a header, and communicate that to the workload through an HTTP header.
Thanks so much.
You're good. Right. Thank you so much.